Hello. Today is July 22nd, 2025. This is SIG Node weekly meeting. Welcome, everybody. Today, the only agenda item is from Praveen. So take it away.
Uh, cool. Hey everyone, my name is Praveen. Today I'm going to be talking about like how we could use DRA to make like guaranteed CPU allocation and also align them with like other DRA resources that are like present on the node. This topic has come up of a couple of times in the working device management working group meeting, but today like wanted to like give a demo of like how resource alignment would work and also uh, get more feedback from the broader community. um, yeah, like starting off with what we have today in terms of guaranteed CPU allocation. uh like kubelet does provide a way to do this by like a combination of two settings. Like one, on the node side we need to enable like static CPU manager policy with additional options like available to control more granular settings. And the other one is like through the pod request we need to make sure the pod is like guaranteed QoS pod, and the way we do this is by setting request equal to limit. And yeah, like kubelet will reserve a chunk of CPUs specifically for this container, and prevents like interference from other containers. uh Parallelly, like on the resources side, like we have DRA, which kind of helps assign allocate resources like GPUs and NICs through to the pod. And the way we do this is through like resource claims. In this example, we are requesting like GPU and a NIC, and the powerful option here is like through constraint we can ensure that like the resources that we are requesting through DRA, all of them align on or match on a particular attribute. In this case, like we use PCI root as a match attribute to make sure like the GPU and the NIC are aligned. uh, so the biggest challenge with this approach, with this currently, is like we have like the node, the CPU manager on the node, which is kind of responsible for like allocating CPUs, and the control plane, like the DRA scheduler plugin on the control plane, which looks at like resource claims and assigns like the other resources like GPU and NIC to the pod. And it's like very well possible that like uh, the container would get CPUs from one NUMA node, and the scheduler plugin will assign other devices from another NUMA node. And this particularly is like a problem for like high HPC workload, which is like highly sensitive to locality or like alignment between CPUs and other devices as well. uh, this is one problem that we currently have, and the other one is like basically the static manager policy is like currently like a one size fits all model, and it lacks like some of the granular information that might be like helpful for like high performance workload. Like we don't currently have an option to specify if a workload needs to use like efficiency course or like performance course or like sub NUMA groupings and things like that. So it's mostly under like kubelet CPU manager control on like what CPUs get assigned to the pod, and the workload, all it can do is like request for guaranteed CPUs. And this is what the DRA CPU driver is like trying to solve. And uh, yeah, like in this example, it's kind of similar to the resource claim with GPU and NIC, but with an additional request for like a CPU device. And again, like we are using the match attribute in the DRA resource claim to make sure like GPU and NIC align on the PCI root, and like the CPU and NIC align on the same NUMA node. So eventually, like all the three resources, CPU, GPU, and NIC, are would eventually be aligned to the same NUMA node. So yeah, this is I can like share a demo of like what how this would work. So let me just stop sharing for a minute and let me share my entire screen. Is my like terminal like visible?
No, just the
Okay, let me. Uh, is it okay? And hopefully it is like. Let me know if this is not like if the font is like too small or something. So here I have a cluster uh, with two nodes. One of them is a node which has like GPU and IDMNX, uh, like the first one, and the other one is like a default node which doesn't have any GPUs or IDMNX. So basically, like let me just. I've also SSH to the node with RDMA on the top right. So if I look at the topology of this, so we have like two NUMA nodes, like 128 CPUs in each NUMA node. And also, if I look at all of the interfaces, yeah, like we have like 8 RDMA NICs. Four of them are aligned with NUMA node 0, and four of them are aligned with like NUMA node 1. This cluster doesn't have any like DRA drivers like running, so we don't have any resource slice. So let me just like uh, I'm currently installing like the DRA net, which publishes the resource slice for all of the RDMNX. I'll also install the uh, CPU DRA driver, which publishes the resource for CPU. So now, yeah, like if we look at the resource slice, we have like one DRA net resource slice which is for the node with the RDMA NIC, and we have like three CPU resource slices. One of them is for the smaller node, which has only one NUMA node, and the other two are for like the other node with two NUMA nodes. So, like theoretically, we could just have like one NUMA node. I mean, sorry, one resource slice for each node. But because of some constraint on like how many devices a resource slice could have, like I had to split it up into like two like resource slices. So if we, yeah, this is the DRA net resource slice. So basically it should export like all of the, yeah, so it's currently like exporting all of the RDMA NICs, and along with the device it also has some properties like the PCIe root complex, and it also exports like NUMA node, like IP address range and things like that. Uh so four of them, like GPU 7 to GPU 4, I think 4, yeah, 5 are in NUMA node 1, and the rest of them are in like NUMA node 0. So if I look at the CPU resource slice, yeah, currently like this is how a resource like CPU is represented through a resource slice. So we have each CPU as a device, and it has associated properties like NUMA node and the core type, and like socket ID, L3 cache ID, things like that. We could potentially like have more properties in here. The reason why I have like DRA net slash NUMA node is a hacky way to make sure I can use this as an example to show like alignment. And yeah, like all of the CPUs in this resource slice correspond to NUMA node 1 is like 0, uh, and the other resource slice would be like NUMA node 1. Yeah, like all of the CPUs in here is like NUMA node 1. So we have like basically like 128 devices in this resource slice. uh, that is about like the setup on the node. So let's look at like an example how we can like get this alignment working. So I have a resource claim, and through this resource claim what I have is like I'm requesting three nicks from DRA net, and all of them like having like all of them being RDMA NICs. I'm specifying this through the selector, and I'm also requesting like 8 CPUs through DRA CPU. And I'm mentioning this constraint as like NUMA node, so that like these two devices we get from the same NUMA locality. Uh, I'll just like apply this. Uh, I also have another resource claim which is kind of very similar, but except that it requires like two NICs and 4 CPUs. I'll apply uh, that as well. Sorry. Okay, so both of the resource claims are now created. So uh, I have like a pod which is using this resource claim. So basically, it is in the spec in the claim section we have this pod using like 3 NIC and 8 CPUs. So if I apply that, yeah. So now this pod is running. So if I check the resource slice again, oops, sorry, resource claim. So we have like one of the resource claim which is allocated. So if we take a look at this claim, so this is allocated to HPC workload 1, which is the pod I just created. And in this resource claim, we see that like it's assigned to GPU 1, uh, and there should be another one. So it's assigned to GPU 1 and GPU 0. Uh, GPU 0, 1, and 2 because we requested like 3 NICs. And it is assigned to like CPUs 1 or sorry 0 through 7, like which is the 8 CPUs that we requested. So basically like both of these are aligned on the same NUMA node. If I So this is a node like on the top right. So uh yes, like I just wrote a script which kind of looks at the C group settings and like exports like the CPUs that the pod is running on. So uh, yeah, so this is a node like the C group setting kind of reflects like what is assigned by the like control plane through the resource claim. So this pod is like running on like 0 to 7 CPUs. And I also had another like best effort pod which is like also running on the same node. So this doesn't request like any guaranteed CPUs. So uh, if I take a look at the CPUs assigned to the best effort pod, like it should reflect like all the remaining CPUs like available on the node. Yeah, so 0 to 7 is assigned to guaranteed, and the best effort gets like all of the other CPUs in its CPU set. So now, like on NUMA node 0, 3 NICs are taken and 8 CPUs are taken. So if I create another pod like which requests like 2 NICs, oops. Uh, So this pod like requests like two nicks, and basically if we look at the resource claim for this pod, so this is the resource claim. If we take a look at the resource claim for this, so the second pod is assigned GPU 5, GPU 4, and like CPUs 59 through yeah, I think 55 through 9. We can also check on the node. Yeah, 56 through 59, and like GPU from, I mean, sorry, NIC from node 1, which is like, yeah, RDMA NIC from node 1, which is GPU 4 RDMA 0, GPU 5 RDMA 0. So now if we take a look at like the best effort pod which was running, these CPUs must be removed from the best effort pod. So now like it doesn't run from 0 to 7 and like 56 to 59, and like the remaining CPUs get assigned to the best effort pod. uh, so yeah, this is the demo part that I had. So I can go back to the slides now. I can pause here as well, like if there are any questions related to the demo itself. Okay. uh
Thank you,
yeah.
Praveen. Not necessarily related to the demo. This is great. I think this seems like a fairly canonical use case. Could we take like a action item to add this to the DRA example driver library of sort of reference examples of DRA?
Yeah, makes sense. So but the current like the daemon set that I'm running, it's in my like private repo. Something that I'm like playing around with, so it lacks like a lot of like testing and things like that. And also there are a few things that we need to get like alignment on how this DRA driver should look like. So yeah, that is something like I can take it as a follow-up, but it would, I think, more need like more discussions on like before we add it as an example.
Okay, great. Makes sense.
So Tyrus?
Yeah, thanks for the demo. I have one question. I mean, you mentioned CPU manager, but I mean, what you have just demonstrated is that we could, with the DRA, actually, all the policy options that we have today, it will end up in a YAML with the rules. So my next question to you is, I assume, are there any plans to expand this with memory as we have today, topology manager? We actually have the CPU, the memory, and the device. So now you demonstrated the CPU. So I'm wondering, are there any plans to be expanded for the memory and for the device? And yeah, that's the question.
Yeah, so currently like I think it only works with this driver, only works with like CPU for now. But like there are some like if I can go back to the slides again, like the biggest drawback that we currently have with this, I wouldn't say drawback, but like a requirement that we have with this is like we need to disable the CPU manager settings on the kubelet side, because we shouldn't have like two things competing for like setting the same C group setting. So I mean, yeah, I did forget to mention that like yeah, like currently on this cluster the stack is disabled. I'm I don't know, I'm hearing an echo. I don't know like if it's me or
It works now. I think the cert has fixed.
okay. Okay. Yeah, like as I was, if I can go back to the slides, this is one thing that I captured as a limitation. it currently doesn't work if the kubelet policies are enabled. And I think this is one of the key things that we need to get alignment on like eventually how like a CPU, a DRA driver and kubelet like standard resources should work together. That is something that I wanted to like bring up in this discussion, because yeah, we need some form of like communication between the node like kubelet or like NRI or whatever is allocating CPUs with the control plane, like the scheduler plugin, which is responsible for like allocating CPUs from the DRA side. So currently we lack that. Yeah, like once we have a clear direction of like how things would work with both of them, maybe that is a better time for like expanding the scope of this to include more things. So I don't know if that answered the question, but yeah.
Yeah, this answers, but I'm wondering, I mean, if someone enables the topology manager and then it has the memory manager, then I guess there is some contradiction. So if I create a pod and then I will use the memory manager, I'm not using the CPU, but then I'm using the DRA for the CPU, then how things work together.
Yeah, I think that's
I
a
think
good
it's not
question.
only the CPU. I have a feeling the topology manager, or?
Yeah, I think like currently it would break in the sense that like we could have a memory C group setting assigned to a different NUMA node and CPU being set to a different NUMA node by the DRA driver. That is something that we need to like figure out, in my opinion.
Okay, and the exclusive CPUs and all these are handled, correct, by the DRA? I mean, these kubelet configurations that we have, system reserve and all these things?
The DRA driver currently only handles like exclusive CPUs, so there is no way to request shared CPUs through the DRA driver. So how this works is like for shared we have like the kubelet, which is kind of like managing setting the other C group settings. For exclusive CPUs we set the CPU set through the DRA driver. So that brings to the second limitation that I've mentioned here. So basically we need the request in the resource claim to match with the request made through standard resources to make sure like the accounting part on the control plane side like doesn't break. So if in the example here, if you see like I'm requesting 5 CPUs through the resource claim, but also we need to request like the same amount through the standard resources so that like the scheduler knows how much CPU is available for like rest of the like the best effort workload pods that could be scheduled on a node. So yeah, this is again like another limitation currently, but maybe like for both of these, once we have a clear roadmap of how kubelet and DRA driver would work together, maybe a common solution would emerge, like which would handle like both of these limitations.
Okay, thanks for your answer and very cool demo. Thanks for that.
Yeah, Francesco, Marlo, I don't know like who raised their hand first.
Marlo should go first.
Just really quickly, it is potential that we could do an admission controller that goes and updates the resources for native resource claims so that you don't have to have a fight between kubelet and the DRA driver regarding resources. But also in this driver, this is the first round, but we did have plans to be able to handle shared resources as well, or shared cores as well.
Yeah, the one of the potential mitigation that I've mentioned is like DRA, there is a KEP which kind of automatically creates a resource claim for devices like requested through like standard resources. Maybe an extension of the same could work for like CPU as well. That is something that we can explore, or like the other alternative, like having a admission controller which kind of creates a resource claim could be explored as well. Yeah. Francesco?
Hey, thank you. Very nice demo. This is a very interesting line of work. I have a couple of questions actually. First, I had a look at the slides you shared, and you mentioned the NRI and the combined NRI DRA driver, which was demoed some time ago in the device management working group. My question is, how your driver and that driver interact, if they interact. I mean, you started from there, it's completely different approach. We need both, we need just one. What's the relationship between the two?
Yeah, good question. I think I had this in the next slide. So currently the DRA, there are two main components. Like, even the way it works, like there is the DRA driver, which kind of like manages the resource claim and like communicates with the kubelet. The actuation actually happens through the NRI plugin, like where we have like a create container hook, where we read like what CPUs are assigned by the DRA plugin, and go and modify like the container, like adjust, I mean, CPU set, not directly, but through like modifying the OCI spec. So yeah, that's how it currently works. So like once the DRA driver prepares the claim, it creates a CDI file which has information for like what resource claim gets what CPUs, and the NRI plugin like will get a callback when a container is created, and it will look at the same CDI file and do the actual actuation. So yeah, like we would need both the DRA part for managing resource claim and the NRI part for actually like more actuating whatever is decided on the DRA side. So that's how it currently works as well.
Yeah, thank you. So conceptually, we need the DRA front end. Well, as it stands now, conceptually, we need the DRA front end and NRI, let's call it back end, to do the actuation.
Yeah.
Yeah, that makes sense. And so I have actually a lot of questions, but I guess the most pressing one ties to the most pressing question I have now for after this demo is the resource representation, which is in the current pod spec. If I ask for 5 CPUs, I don't actually know what I'm getting unless I go check what the kubelet on the node, the pod length, is configured to. Because the exact same pod spec give us either 5 exclusive CPUs or CPU time equals to 5 full CPUs, depending on the node setting, which is the CPU manager, and that's fine for now. But the question is, how do we have a plan already to disambiguate, or a direction or any idea about how to disambiguate that going forward? Is something that has been talked about?
Uh, so the current like representation of the resource claim, it's based on like what we have in the DRA in GK133. So yeah, one of the like big scalability concern that we have, I briefly mentioned that in the demo as well, is like it has a limitation on like number of devices, and for bigger machines like we quickly run into that limit. So that is one concern, and the other one is like we haven't like looked at the performance overhead on the scheduler side or on the node side to manage like all of these. But yeah, like we have been looking at newer DRA features like consumable capacity and like partitionable devices and things like that, to basically not having to export like each CPU as a device as a potential option, and have like a more logical representation. But I think it's like it's still in the early stages, because the feature itself is in the like the consumable capacity or like partitionable devices. The feature itself is not like it's in early stages as well. But yeah, the general direction, yeah, I think like we should start thinking about how to uh, make the resource like slice more manageable, and avoid like exposing too much information within the resource slice.
Thank you for your question. I'm happy with the answer for now. I will totally follow through offline, and I look forward to collaborate. I just want to mention the reason why I'm asking now to explain, and then I really don't. Because I believe I am under the impression that this form of representation, this disambiguation between I'm asking 5 and I mean 5 exclusive. No, I'm asking 5, I mean CPU time for 5 equals to 5 cores, is something that can drive the API and could have ripple effects to the implementation. And so I fully agree. This is very early. This is fully experimented. This is a promising experiment, but I think that this is one of the things that should be taken into account from the beginning to avoid to run into dead ends. But it's my idea. Maybe I'm wrong. So this is just the context for my question. Thank you again for the demo. Really promising work. I look forward to collaborate.
Yeah, thanks for the question. I think I've linked a doc as well along with the slides in the meeting notes. I have explored like some of these. It might be missing some details, but I'll continue like taking a look at those and like add more details soon.
Great. Hey, thanks for the demo. This looks awesome. So one question I have is the eventual goal here to make this be the thing that is an alternative to the inbuilt ones, or this is just one CPU driver? Like, do we have aspirations to be the only single CPU driver, and then it works for, it doesn't matter which vendor chip you're using?
Yeah, I think the DRA framework itself, like it could, I mean, we could have like multiple like DRA drivers like based on use cases and have like different models to represent like CPUs within those DRA drivers. The current plan is to have like a, I think like a reference driver that can work for most cases, but also yeah, like serve as a reference implementation to build on top of. And regarding like if this could be the only, like if the DRA driver could be like the only thing responsible for CPU like guaranteed CPU allocation, yeah, that part I'm like we are not quite sure yet like how it should work with like kubelet already managing these and like potentially avoid overlap and things like that. The other reason is like we already have like other features within kubelet, so would we have to, if this is the only way to get guaranteed CPUs, like would we have to like implement all of those within the NRI driver also, like have duplicate implementation for like things like say in place pod resizing with guaranteed CPUs and things like that. So I think, yeah, personally I'm not very clear on.
Yeah, I think my question was more around the lines of, like, as you said, right? DRA is very flexible. So are we gonna have like 5 of them, and then, oh, my pod YAML only works if you have these drivers enabled? And so I'm hoping that eventually there is a fewer number of these drivers and everyone works with them, and we don't lose the way where the pod YAML will work no matter which cluster you're running it on.
Yeah, I think like if we, I don't think I have a very good answer for
Yeah,
that.
no, that's okay. This is still early, so this
Yeah.
is yeah.
Yeah.
Thanks for the demo. Yeah. Swati.
Praveen, thank you for the demo. I just want to ask a couple of questions. You mentioned that you're using DRA driver along with NRI plugin. I just want to understand a bit more how is that the way we are implementing it? Is it that in a single process we have multiple threads? One is the DRA driver and the other one is NRI plugin, or they're running as separate pods?
In the current implementation, like we have a single daemon set pod which has like both the like the DRA hook and the NRI hook, they're not like separate processes. Like the container runtime will call the the NRI hook whenever the container is created. But yeah, like all of the state, like as to what pods are assigned to what CPUs and resource claims and things like that, that is managed within the same daemon set pod.
Okay, got it. So that brings me to my next question, which is this particular pod is extremely important infrastructure pod.
Yeah.
And how do we protect it from, potential resource contention and scenarios where the resources are consumed by workloads, and we need to essentially make sure that this particular pod is protected from resource perspective and has guarantees around it. Um, so that is kind of part A of my question. Second one is, again, the ordering aspect. We don't have control around how in kubelet restart or node reboot scenarios these pods appear. So there could be a scenario that the pod that is requesting your resource comes up before this DRA driver. So I'm curious to understand how we would handle scenarios like that.
Yeah, like the pod not being available when the daemon set not being available when the pod with guaranteed CPU is created. I think that is a very valid scenario in case of restarts. And like the NRI hook already has like a synchronized call which kind of loops through all of the pods and containers within the node. So in the current implementation we are using that to kind of create that initial state, and also like do the actuation when the daemon set pod itself is starting up. So that is like one way. And regarding like ordering, yeah, I think like that's a good question. Uh I haven't thought too much into like resources and like ordering of other daemon set pods as such. Currently it's like running as like a burstable pod. So yeah, that is like a action item that I need to explore, I think.
Yeah, so if it's a burstable pod, what is preventing it to be evicted, in case we have guaranteed pods that are requesting a lot
Yeah.
of CPUs, for example?
Yeah, I think that's a good question. Yeah, I don't know if this can be a guaranteed pod, because like if this is responsible for assigning guaranteed CPUs, I don't know if we run into this chicken and egg situation if we have this also to be a guaranteed pod. But I will like look into this and like get back
Yeah.
on the.
Yeah, I think you did touch on the bootstrapping issue that I wanted to talk about as well. I think that is another thing that we definitely need to consider as part of this. How is this infrastructure pod deployed? Um, it also requires CPUs, and it's serving as a component that allocates CPUs. So, like you said, chicken and egg problem.
Yeah.
I was going to say we will probably have a set of
Yeah.
NRI plugins that can. Sorry, that we'll probably have a set of NRI plugins that can operate at system D level. As services that are on each host, so they don't necessarily have to run as a pod. It just has to be a daemon with root access. Okay.
Okay.
And those are TTRPC calls. Just an FYI, and it had to be at the root level as well, which is the same as the container runtime. So it should be up and running, and the init proc is just going to happen. The initialization is just going to happen on restarts and when you actually load your daemon in the first place.
So if there are no other questions, so that's everything that I had for this presentation. Like, and if you want to like it's pretty easy to try out things. Like for the DRA side, we have DRAnet, which Antonio is like working on with others. For CPU, we have like a couple of implementation. Like the one I had today was like the driver that like we are working on. There is another implementation with like there is an existing topology aware NRI plugin, and there is a DRA front end like for that, which also works in a similar way with respect to like how resources are represented and like resource claims are used. But the main place where it differs is like how existing guaranteed CPUs are managed, because like the topology aware plugin already looks at the pod guaranteed CPUs and does a lot of things like memory pinning and isolated CPUs and a bunch of things. And it also has ways to like specify settings through like the pod spec and things like that. Not sure if that is like a uh, uh, yeah, that is something that we want to have. But yeah, eventually the main thing currently is like if we can align on how kubelet and like the CPU DRA scheduler plugin would work and avoid overlap, that is something that can help define like how the reference driver would eventually look like. So yeah, that's everything that I had for this presentation.
Thank you, Praveen. I just checked, there is no new agenda items. So if nothing else, we can conclude the meeting. Just a reminder, code freeze is coming. So if you have anything that you want to merge, ping your reviewers and approvers. Thank you, everybody.
Thank you.
Thank you very much. Bye.